I would like to introduce Pranith Joy as our panelist today. Pranith is a product manager overseeing industrial backplane connectors for the ACPI business unit at Amphenol Communication Solutions and brings a wide range of experience and technical solutions of automation products. Thank you, Pranith, for joining us today. You now have the floor.
Thank you, Greta. Thanks for the kind introduction. Good morning, all. I would like to take you all through one of the fastest growing and the most demanding application in the industry called industry automation or factory automation. The segment has a growth rate of 8.2%, accounting to $220 billion in 2027. The US market accounts for the largest share in 2021, and we foresee to continue the trend in coming years as well. The classification of industrial automation is broadly based on component level, solution, industry, and region. But we mainly focus on our connector segment, finding application in components and solution. The focus components and solutions are highlighted, and the market for the industrial automation is always dynamic in nature. And the key drivers affecting the major market is the adoption of IoT and artificial intelligence with the optimum utilization of resources. But the main restraint what we foresee is that huge capital investment and the maintenance cost. And the opportunity what we are seeing is the adoption of Industry 4.0 principle for the manufacturing. And while adopting to this opportunity, we see a challenge that there is no standardization in industrial communication protocol or the interface being used. So there are a lot of cyber attacks happening all over the globe, and we need to find a way out of this. And together we are trying to build a precise, specific system which is user-friendly and non-breachable. So I'd like to introduce the major equipments used in factory automation, and we will discuss in detail regarding this architecture of each of the devices. First, we'll start with drives. So drives is nothing but the devices which operates and controls the speed, torque, and direction of the object or the device. And we are using electrical motors for this operation. And we can use either DC motor or AC motor to meet the requirement. Hence, it is classified as DC drives and AC drives. If we are using a DC motor pertaining to the application, it is called DC drives. And if it is AC motor pertaining to the application, it is called AC drive. Both the drives follow a similar type of architecture. And our backplane and I/O connectors are an ideal fit to their design requirement. Next device I would like to introduce is programmable logical controllers. In this image, you can see the modules of a PLC. So there are different types of modules called, first is a power supply module, next is the CPU for the backup, and there are different modules called digital input, digital output, analog input, and analog outputs. So our connectors are like backplane and I/O connector system is perfectly fit into the modules. The third devices is the control and automation system. So control and automation system are segregated into three parts. First is the drive control. As I mentioned, drives as DC drives and AC drives. So these drives has to be controlled into these parts, and these drive control focuses majorly on the control of the drives with the system of arithmetic component referencing, and these are modular in nature. As you can see the very image of the DC drive control, and these are modular in nature. Next control system is motion control. It focuses more on precise control of motion, position, and velocity of load operating devices. And these motion control devices focus more on the multiple choice of buses, and which helps in optimization of the system. Next, control device is CNC machine control. CNC machine control, basically known as computerized numerical control machine, and it is heard of the industry, and this control device plays a pivotal role in controlling these machines, and our connector are an ideal fit for this modular system. Next is the industrial communication, which is a major part while sending the data or receiving the data. So these communication devices are majorly classified to three. First is industrial switch. Like we are sending the signals across different networks. So if we are to send the signals across the same network, we use industrial switch. And if there is the signal need to be sent across different networks, we use industrial routers. And there is multi-networks and multi-protocol involved in sending a signal from one network to another. Then we use gateways. So all these industrial communication devices, our backplane and IO connectors are the perfect fit. Next one is industrial robots. So it is through robotics where there will be decrease in need of physical power, and there will be increase of productivity, and there will be any elimination of errors. And this helps to attain the accurate, flexible, and high-speed operations. So again, the robots are classified into traditional industrial robots and collaborative robots. So the difference between traditional robots and the collaborative robots is the degree of motion in which they perform their action. So again, traditional robots are classified into 4 robots. First one is articulated robots. Articulated robot, as the name suggests, articulated means jointed. So it has joints. In case of articulated robot, it joints vary from 2 numbers to 10 numbers of joints. While coming to Cartesian robots have 3 principal joints, and one of them are linear, and they are right angle to each other. So they move in a right angle fashion. Third robot is selective compliance assembly robot arm, SCARA. So they are parallel axis robots, and their arms in X and Y direction. So they are having third arm in Z direction, that is the third direction, but it is fixed. So they tend to move in X and Y direction with their third arm fixed in Z direction. The fourth robot is parallel robot. So parallel robot is having a configuration of a parallelogram with a 4-bar linkage and with a 4 degree of freedom, which is 3 translational motion and 1 degree of motion is rotational. So these are one of the most common robots used in industry. Next robot is collaborative robots. So next, depending on the degree of motion, we are classifying the robots into traditional and collaborative. So collaborative robots are the standard robots with integrated sensors, vision system, passive component system inbuilt in the robots. And these have an option of integration of artificial intelligence in this robots. So what happens is that it can be adaptive in nature. So, and this is the future of robots, and it is also known as cobots. So we promote our connector called Compact Home and D-Sub into this robotics segment. These are about robotics. Next is industrial PC. Industrial PC, as you know that the rack mount PCs and the box type PCs are used for computing the analytical and a technological trending process involved. And our connectors, backplane connectors, are ideally used in the rack mount PCs and the box mount PCs. These are in the HMI servers and server rooms. The process analytics and controllers, these are the last devices used in the factory automation. And as we all know that there is always a process involved in the functioning of a machine. And how do we analyze the function of a machine? So what we do is that there are certain byproducts of the machine which we would like to collect and analyze the performance. And there are certain byproducts like oil, gas. So these byproducts are analyzed using a process analyzers. So these process analyzers are basically modular in nature, and our connectors are used for analyzing this byproducts by sending the signals. and there are process controllers and protection devices. So what happens is that these are controllers and protection devices with which there is proper functioning of the machinery, and which helps to avoid the interruptions and breakdowns of the equipments. So there is a huge uh, cash being seen from the machinery being not worked. So this helps in very pivotal function of the machinery function. So in these protection and controller devices, also connectors, backplane and input-output connectors are being used. These are majorly with the connector application part. I would just like to take you through the connector world. So I would like to introduce about the industrial backplane segment. And in this industrial backplane segment, I would like to introduce there are three basic connectors, which is millipax, metral, and DIN. Millipax and metral is having a pitch of 2 millimeter in length, and DIN is having a pitch of 2.54 millimeter in length. Millipax follows a Hartmetric standard, while metral is following a future bus standard, and DIN is following is DIN 41612 standard. So our backplane connectors are tulip contact-based design, which is of high reliability. We have signal, power, and hybrid version connectors available in our range. We offer the data rate from standard 3 GB per second to 25 GB per second availability. And our connectors are vibration and shock proof with US Car V2 compliant. This is our very landing page of industrial backplane. So if you come to this very page, you can select your own connector depending upon your requirement. The filters available are protocol, the pitch, the signal rows, and the data rate. And the maximum data rate available with us is 25 GB, and the maximum rows is 8. So you can make your select your own connector depending upon the design requirement. So this is the easiest tool available in our landing page. I told you that we are offering an industrial backplane connector with millipax and metral of similar pitch. The major difference between millipax and metral are the board-to-board distance, the card slot width, the PCB hole diameter. So these are the major key differences. So a designer can choose the key differences based on these points. Next, I would like to discuss in detail regarding this each of the connectors. Like first one is millipax. In this very image, you can see the vertical header and right angle receptacle of millipax connector. So millipax is the only backplane connector with top and bottom row shielded, and this is a only connector with a speed range of 25 GB per second. And we are offering the connector in 3 contact mating levels. So with this, what we attain is the FMLB, first mate last break, and last mate first break option. So this is available in power, low speed, and high speed version, and also available in power, backplane, mezzanine, coplanar, and board to board version. Next is metral. Metral, I told you that this is a connector having a pitch of 2 millimeter in length. This is one of the most complete backplane system because it is offered in signal, power, coaxial, cable versions. Also available in the termination of solder to board, pin in paste, and press fit version. And these connectors are modular and robust in nature. These are available in mezzanine, backplane, and coplanar configurations. The third connector falling in industrial backplane is DIN 41612 connector. Again, following the standard of DIN 41612, pitch of 2.5 millimeter in length. This is available in a standard mount, reverse mount, and cable mount. And again, coming to the termination, we offer solder tail, press fit, wire wrap versions. And one of the key feature I would like to highlight for DIN is DIN connector can withstand up to a temperature of 175 degrees centigrade, which is EN 45545/2 certified, which is smoke and fire compliant. The next connector, which is the most common connector, which doesn't need any introduction, which is known as D-sub connector. This is a most common interface connector used in the worldwide and in the factory automation segment also. So we offer the complete portfolio of these connector, and these connectors are available in both terminal, both applications and cable side as well as, and these are available in press fit, IDC, then pin in paste through hole terminations. So these connector have a lot of scope in factory automation application. And this is one of the recent connector we are launched from a business unit, and this is not a compact combo. As the name suggests, this is having a combination of both signal and power. Currently, we offer the compact combo in 6 signal and 5 power version. The signal is having a current carrying capacity of 4.5 amps with a wire gauge of 24 AWG, and the power is having an ampacity of 32 amps and the wire gauge capacity of 10 AWG. So we find it good application in robotic arms, because in robotic arms the application is having both signal and power to be transmitted simultaneously. So our connector finds a perfect fit of application in robotic arms. So these are regarding the uh, connectors and the application side as well. Right.
Awesome. Thank you, Pranith.
Thank you. Yeah, thank you. Thank you all for
Thank you.
listening. If you have any queries, you just ask and I can come back to you.
All right. So Pranith, it looks like we do have our first question in. And
Okay.
our first question is, are these connectors intermatable with other popular parts on the market?
Yes, these connectors are intermatable, and all these connectors are based on IEC standards. So we can have the intermatability possible since if it is following IEC standards.
Perfect.
I hope I have answered the question.
And we do have some other questions coming in. The next one is, can the same backplane connectors be used for DC and AC drives?
Of course, same backplane connectors can be used, because what happened is that, as I told in my slide, that DC drives and AC drives are having similar architecture. Only the mode of operation is different. When DC drives are used, it is depending upon the DC motor, and AC drives are used depending upon the AC motor. Only the during the power supply and the major circuitry difference is happening. So the architecture wise, the both the drives like DC drives and AC drives are similar. So you can use the same connector and interface connectors as well.
Great. And we do have our next question in, and it is, what would you say is the major difference between traditional and collaborative robots?
The major difference between traditional and collaborative robots is that traditional robots is being used in various levels of degree of motion where it is less constrained. And in collaborative robots, the advantage is that the degree of motions are more, and we have a feature of in-house IoT sensors and various passive control system enabling in the robots. So this feature is not available in traditional robots. So traditional robots is used where there are less features involved, and collaborative robots or cobots are used where there are more complex and more functions are required. So basic difference is the degree of motion.
Thank you. And our next question is, how does a PLC function?
PLC function, yes. PLC function is that, as I told you, that there are various modules in a PLC. Like there is a power supply, there are CPUs, there are digital input, there are analog inputs. So the inputs are received from the field devices, like maybe from an IoT, and the input derived from these field devices are processed in a PLC, and the output is to control the desired operation, like if you want to on or off a breaker or a switch. So input received from the field, then PLC process it whether we need to whether the condition is optimal or it is over the limit, then PLC takes a decision to control it. So PLC receives input from field, and it controls it by sending the output.
Thank you. And our next question is, are these legacy connectors supported for a lifetime or just a minimum of 10 years?
No, actually, these are very proven connectors, and we can support more than 10 years. These connectors having a longevity more than 10 years.
Great. And for our last question that we have here is, do you support board assembly or cable assembly?
We can support both board assembly as well as cable assembly, and cable assembly, depending upon the customer configuration or the customer requirement, we support them, because there are different customer requiring their own wire sizes and wire gauges, and we support depending upon the customer configuration.
Awesome, thank you.
Thank you.
And that is all the time that we have left for today. And if we did not get to anyone's questions, or if you want to ask any questions, please feel free to ask. And I will be sending everyone a Q&A transcript to review afterwards. I just want to say thank you for joining us today and learning more about factory automation with Pranith Joy. Thank you, Pranith.
Thank you, Greta. Thank you all.
Thank you.